Hello everyone, welcome in. We're doing some general psychology this morning here. I'm just setting up my camera. Good morning everybody, good morning. Good morning. Good morning everybody. Hope you're enjoying your weekend so far. I'll go ahead and get started here in just a couple seconds. But how's everyone doing? Hope you had a good weekend. We're going to do some general psychology stuff, and then we're going to move into the nervous system questions. Thanks for joining, and thanks for liking the live. I really appreciate it. The more that you guys like the live, the more that this will get stuff out to people, so we can help them on their upcoming exams. But thanks for all the like, guys. Thank you. It's good to see you all again. Just a second here, I'm just fixing something. Alrighty, welcome in. Hold on a second. Alrighty. We'll go ahead and get started here in just a second. Hello, welcome in. Let me go over some general psychology. Hello, welcome in. Thanks for liking the live, everybody. Alrighty, that should be good. Yeah, there we go. Alrighty. I use GoodNotes, so I'm currently using GoodNotes right now. Hello, welcome in everybody. We're gonna go ahead and get started here in just a second. I tried Notability, but I personally didn't really like it that much, to be honest. What pen type do I use? Most of the time I use the fountain pen. You're able to see my settings. Let me move this up a little bit. So I use the fountain pen. I use 50/50. And then kind of depends on the pen size. So for whenever I'm like kind of zoomed in a little more writing here, I use a 0.25. And then whenever I have like kind of the medium thing, which is whenever I kind of make I'll make my titles like this. I use 0.55. And then this kind of ranges, this big pen. I have it all the way up right now. But most of the time I think I have it on like it's normally on like 1.5, I think. Yeah. Which I don't really use this a lot, to be honest. Sometimes I do, but I can't really think of anything off the top of my head that I actually use it for. Hello, welcome in. We're doing some general psychology. We'll go ahead, now that we got some people in here, we can go ahead and get started. This is GoodNotes. This is what I use to take notes. Alrighty. How's everyone doing this morning? I really appreciate you guys joining the live and liking the live. I'm going to go through and we're going to talk about we're going to start talking about thank you for following, the nervous system anatomy. So, thank you for following everybody. Thank you. It's good to see everybody in here. So the first thing we're going to cover here is pretty much like the anatomy of the nervous system if you're just joining us. So, first, you obviously have the cells of the nervous system are called neurons. Is everyone like familiar with a neuron and what it is? This is GoodNotes. I use GoodNotes for all my notes. Thank you everybody for liking the live. I really appreciate you guys. Good morning everybody. It's Sunday for me. It's currently like 10 a.m. So again, we'll get started here. Again, we're doing the nervous system anatomy right now. Thank you, Jody, for all the roses. What degree do I have? We're doing psychology this morning. So I did mean to write psychology. I have a degree in molecular medicine. I have a master's degree in molecular medicine. Thank you for all the roses, Jody. I really appreciate you. I got my undergraduate degree in, I had a double majored in kinesiology and biomedical sciences. Starting practical nursing. Awesome! Oh, I'm starting practical nursing. Good luck, you got this. I love anatomy. Yeah, me too, I love anatomy. Right now we're doing some psychology just because it's been requested that we go over some, but we're going to start off with the anatomy of the nervous system, which is beneficial for anatomy and physiology, obviously. All right, but without further ado, we can continue on here. So, the anatomy of a neuron. So, neuron anatomy. Obviously, it has a cell body, and we'll go ahead and draw one here in just a second as well. We have dendrites, the axon, the myelin sheath, the axon terminals, and the node, not nade, nade out, nodes of Ranvier. So, take a look at the comments. All right. Thanks for all the likes, everybody. So, our cell body is typically what has our nucleus, like organelles. Our dendrites is what is going to receive the signal. Axon is going to transmit this the signal, and by signal it's an electrical impulse. Our myelin sheath is going to insulate the axon, making it faster and easier. And then our axon terminals is where we are releasing neurotransmitters. And then our nodes of Ranvier, where we have like our gaps in the myelin sheath. So if you're just learning these terms and you're not sure about them, I definitely recommend make some flashcards for these. Speed. So you have these. So what do they look like on an actual picture? Which I'm no artist, but we'll try to draw it out. Thank you for the other heart, Jody. I really appreciate you. You guys are too kind. I hope you guys are doing well this morning. Alrighty, so this is going to be my very crappy attempt at drawing an axon, a neuron. So you kind of have your cell body, and they have these little transmissions off of them. Then bear with me for a second while we get these here. Alrighty. Can everyone kind of determine that this is a cell body? That's a neuron. Yes, it is a neuron. Welcome in. We're doing some nervous system anatomy right now. So, this is for general psychology, anatomy, and physiology, whatever it sort of helps you with. If you're just joining in, welcome. Thanks for all the follows. Thanks for liking the live. I really appreciate you guys. Hope you guys are having a good weekend and good morning, things like that. But anyway, all these little bundles of joy on the cell body, which is this. This is our cell body. This is where our electrical impulses are going to be received. So these are our dendrites. This little circle in here, this is our nucleus. spelled that wrong. And then, so we receive this electrical signal by the dendrites. It goes here, gets picked up by our nucleus, our cell body, and then this long thing here, all the way from the start of this little sheath here, all the way to the end down here, is what is known as our axon. These little things that cover the axon here are known as our myelin sheath. These little gaps is what's called our nodes of Ranvier. And then down here, all these things where we have our neurotransmitter release. So neurotransmitter release. These are our axon terminals. I'm using good notes. Is this medical school content? This is for general psychology or you can use it for anatomy and physiology. Just your normal kind of like just your normal nerve cell. Just kind of a general neuron. Pretty much just like what you need to know for like basic anatomy and physiology or general psychology. Do I do these daily? Yes, I do. I do every day except for Saturdays most of the time. I probably will do one this Saturday upcoming, though. And then I'm going to do some teas reviews here soon as well. So it would technically be considered a motor neuron, but these are just mostly what a general neuron would look like. This is what you're expected to know for like general psychology, anatomy and physiology, things like that. Thanks for following, everybody. Can you explain how this is related to psychology? Well, your neurons are part of your nervous system, and psychology is kind of what transmit, like, how do I explain how it relates to it? Well, neurons are what function in the nervous system and transmitting signals from your brain to your body, and psychology has a lot to do with, the structure of your brain, the mental processes. And for mental processes occurs, you have to transmit and receive signals in your nervous system. Does that make sense? So for in terms of physiology, physiology can occur as a result of a stimulus and a signal, things like that. Does that answer the question there before I can move on? I just want to make sure we're all set on what these are. Before I move on and whatnot. Yes, it would be a multipolar neuron and functions motorly. Yes. Multiple sclerosis, yes, the body attacks the myelin sheath. Yeah, we'll get into glial cells here in just a second. I do have that on my list to go over. But essentially, we'll move on now. So a glial cell, essentially they are non-neuronal cells in the nervous system. They're mainly for support, protection, and nutrition for neurons. So their main function is to basically maintain homeostasis for neurons and nervous systems and things like that. They form myelin, we just went over. So something like oligodendrocytes, things like that. This is a section I'm in for now, so good kind of timing to come across. Awesome, fantastic, that's glad. Our dendrites, the communication part. So they receive signals. So these are dendrites, and they are what receive. So we'll put the electrical signal in red. So it's received here, and then it's sent from the axon terminals on the axon. Alrighty. So, moving on, we also have our structure of our brain. So we have. Anyone tell me what like the major regions of the brain are? So there's our forebrain, our midbrain, and our hindbrain. The forebrain pretty much has our cerebrum, our thalamus. Let me move these down a little bit. Our thalamus, our hypothalamus, and our limbic system. Our midbrain is what's more so in like our motor control, so like our movements, and then also some sensory processing. And then our hindbrain is like what has our medulla, our pons, cerebellum. So our hindbrain is mostly like responsible for controlling our basic life processes. Does that make sense? Hey, just found you. I'm already loving your work. Thank you. I'm so glad to hear that. Thanks for joining. I'm glad you found me. Let me make sure. So whenever our dendrites communication power. Hey, Kelly, how are you doing? Good to see you in here. I am uploading the first. So we went over chapter 1 on Thursday. So that part will be up later today on YouTube. Thank you for getting this good review. I just had an exam on Tuesday. I'm so sorry. But anyway, so real quick here, this recording, as well as chapter 1, will be on YouTube. That's my name, or you can just go to my link in my bio. But the recording of this, so the replay of the live, will be on there. I have a practical for A&P on Tuesday. Awesome, good luck on your practical. Videos are extremely helpful. You're the best. Oh my goodness. Awesome. Thank you guys. I really appreciate you. You guys are going to make me cry. You guys are what make this so much fun to do. So I appreciate you guys a lot. Things like that. I could honestly cry. You guys make me very happy, I promise. But anyway, I can kind of go of... can label these and stuff. So... essentially, let's see if I can draw a crappy picture of the brain. So if we have oh boy, this is rough. All right, so artistic ability aside, Alrighty, so this would be our like this is so bad, I'm so sorry. Forebrain, our midbrain, and our hindbrain. Yeah, we can go over afferent and efferent here in just a second. I'm just watching this for fun. I love anything medical. Thank you for the class. Yeah, no problem. I'm on the nervous system right now in nursing school. Awesome. Yeah, we're going to do some nervous system practice questions in just a moment. We're going to go through psychology chapters 2 and 3. But essentially, afferent and efferent. So, afferent and efferent. So afferent refers to sensory neurons. Essentially, these are what carry, so they carry our sensory information to our central nervous system, which is our spinal cord and our brain. So, signal. So we have sensory information, and that gets conducted as a signal back to our brain, our central nervous system, so our spinal cord and our brain. So, like if you touch a hot stove, that'll send the information that you're touching something really hot all the way to your brain, and this is where the signal goes, and then the signal has to come back to where we received it to have a response. So, efferent would be motor neurons. So this is what is going to take our CNS and signal to muscles, glands, things like that. So, we touch a hot stove, it sends a signal, it carries it all the way to our brain, and then we go, oh, that hurts, that's really hot. So then we send that signal back down to our muscles, and then we move our hand away. So let's... Does that make sense before we move on? Yeah, the midbrain is part of the... Yeah, I know. I just drew it really badly. But essentially, that's kind of where it would be. Is this rage bait? What are you talking about? We're going over the nervous system right now. Yes, essentially. A before E. So afferent toward brain. Efferent is away. Yes. Does that make sense before we move on? Yeah, we're not talking about we're in a completely different body system, my guys. So I apologize if you're confused. I'm sorry if it's frustrating for you, but we can get to that other system another day. Alrighty. So there are key structures in the brain, specifically in the forebrain, which we have our thalamus, our hypothalamus, our amygdala, and our hippocampus. So the thalamus is responsible for sensory... it's like our sensory relay station. Our hypothalamus is what is going to regulate our hormones, homeostasis, hunger, thirst, things like that. Oop. Then our amygdala is essentially like our emotion processing. Emotion process, like fear, aggression. And then our hippocampus is essentially responsible for our memory formation, spatial like navigation, things like that. I have not gone over the key divisions yet. A for away, E for same thing, away, toward. What did I put here? Did I mess up? Yeah, toward, away, yeah. Alrighty. So for body temperature, yes. Homeostasis is considered body temperature, so I'll put that in here. So we can go over our divisions of the nervous system now. So we have two main divisions. We have our central nervous system and our peripheral nervous system. Let me draw a little better. So central nervous system, peripheral nervous system. The central nervous system is our brain, our spinal cord. This is essentially what processes interprets information. So process, interpret, info. For the peripheral nervous system, that's essentially outside of our brain and spinal cord. And this is going to transmit the signals from the central nervous system between the body and brain. So transmit signals between body and our brain. And then the PNS here is going to have some divisions within that. So these are known as the subdivisions. I'm just going to put subdivs. Essentially here what we have is, let me use black for this here. We have our somatic nervous system. I'm going to put an S for nervous system. This is what is going to be for, so somatic, again, always means like body. So this is what is for like our voluntary movements. And then we have our autonomic nervous system. Essentially what this does is this is going to regulate our involuntary functions. So involuntary. Things like breathing, heart rate, digestion, which can further be split into two more divisions, which is our sympathetic and our parasympathetic nervous systems. So our sympathetic is what our flight or fight response is. So flight, fight. And then our parasympathetic is like our rest and digest. The way that I remember this is like, it's kind of like for slowing down, like a like para has parachute. So a parachute slows you from falling down. That's how I just kind of remembered that one. Does this make sense here for the divisions? Hi, Ollie, happy Sunday. Hello, hello. Yes. Thank you for following. Thanks for liking the live, everybody. I appreciate you guys for joining. I take a sip of my energy drink here. I love Lonnie News. I have a new, like, it's called the Strawberry Sunrise flavor. It shows up on my camera. It's really good. Yeah, thanks for following, everybody. I really appreciate it. Moving on, we have our geography of our cerebral cortex. So we have our frontal lobe, parietal lobe, our temporal lobe, and our occipital lobe. Our frontal lobe is going to be essentially like our decision making. It's going to be like our planning, our voluntary movement, speech, so movement, speech, things like that. Parietal lobe is for our sensory processing. This is also for like our spatial awareness, so like kind of like knowing where we are in like a room or things like that. So our awareness. Our temporal lobe is going to be like our auditory, so like our noise processing. So we hear a loud bang, that's what's going to cause us to process that. So speech is I just want to make a note of this. So our Broca's area for speech. So again, like you have to move your mouth to talk and things like that. And the temporal lobe, we're listening to noise. So you listen to somebody speak, otherwise known as language. So this is the Wernicke's area. This is also, there's memory involved in the temporal lobe. Our occipital lobe is our visual processing. Alrighty. So what are some things that the ANS and PNS control? So our ANS is going to be like our involuntary movements or like involuntary processes within the body, divided into like our sympathetic and our parasympathetic. So for sympathetic, an example would be like increasing or decreasing your heart rate or blood pressure, dilating your pupils. Like if you think about it, whenever you are in a room, you turn off the light, your pupils dilate. So you can get in more light. Things like that. For like parasympathetic, it would be like decreasing your heart rate and blood pressure. I say increasing or not increasing or decreasing for sympathetic. Sympathetic increases your heart rate. Parasympathetic decreases heart rate. Be constricting your pupils, digestion, saliva production, urination, bowel movements. The peripheral nervous system is part of that. The autonomic nervous system is a part of the peripheral nervous system. It's a subdivision of it. So the peripheral nervous system is for transmitting like signals between the body and brain. Which I mentioned earlier, we have the somatic nervous system. That's going to be our voluntary movements. So like our walking, our talking, our writing. It's going to process like our reflexes. It's going to do like touch, pain, like if we touch a hot stove, things like that. I'm about to get myself an Alani. Oh my goodness, yeah, Alani's. They are combining with Celsius? I did not know that. Oh my gosh. Yeah, sympathetic stimulatory to all, but digestive para inhibitory relaxation. Yeah, I always think of like I mentioned there, like parasympathetic, it kind of sounds like parachute. Yeah, so Janae, so an example of sympathetic would be like when a cop stops you, meaning it alerts you that there's danger. Yeah, so like, when you're driving along the road and you see like cop sirens and lights turn on, and you like kind of jump a little, and you're like start like you can feel a little bit in your chest. That's like what your your sympathetic nervous system is, and your parasympathetic. If you eat a lot, this is like what would give you your food coma. I know a lot of people say I'm in a food coma. Parasympathetic isn't necessarily when they leave. It kind of brings us down to homeostasis, but. Thanks for and sharing the live, everybody. I really appreciate you guys. So we can go over ageneric and anticholinergic in just a second. So we'll go over these real quick before we move on. So ageneric. I guess sometimes I always have trouble spelling this. And then anticholinergic. These are essentially two different drug actions related to our autonomic nervous system. So these are going to be related to our autonomic nervous system. Adrenergic is what stimulate, so these are going to increase our sympathetic nervous system, so our SNS. For parasympathetic nervous system, because there's PNS, I'm just going to put para for that. So this one is for our it inhibits para. So our rest and digest. So they're going to block the parasympathetic nervous system by inhibiting acetylcholine. So these decrease ACH. Adrenergic is they pretty much act on adrenergic receptors, otherwise known as alpha plus beta adrenergic receptors. So they're gonna increase our heart rate, blood pressure, dilate airways, dilate pupils. This is essentially going to function to also kind of do the same. So to increase heart rate, open airways, things like that. No more AMP, please. So sorry. I have an exam on this tomorrow. Good luck, you got this. Alrighty. Thank you for following, and thanks for joining, everybody. I hope that you are hopefully learning something throughout this. So let's go. So again, now that we know kind of, we went over what our neuron is, we went over the structure and anatomy of that, but we have to learn the actual process of a nerve impulse. Which again is referred to as unidirectional, so one direction, like Harry Styles, Niall Horan. So 1D for all you One Direction lovers out there. I like Harry Styles. He's probably one of my favorite artists, to be honest. But anyway, like I was going over in our anatomy of a neuron here, our dendrites receive a signal when it goes through, and then we output that through our axon and axon terminal. So this is essentially the physiological process of that I'm about to cover. Before I continue on, just double checking. Would you be able to do a live how you study? Yeah, I can do a live for like that. What do I need to go back to? But yeah, I will put these on. I do sell notes. Yeah, they're on my website. They're linked in my bio. I don't currently have any psych notes up right now, but I do have a lot of other systems. This will also be on YouTube and things like that. So I'm a little behind on my uploading to YouTube, but I should be catching up today. I have time. I had a pretty busy weekend, so I should be uploading like 4 or 5 videos to YouTube today. So, if you need anything to binge watch, definitely my YouTube channel if you want to learn some A&P. But essentially, let's go over our process of a nerve impulse. So, let's go over some terms before we kind of graph these out. So we have our resting potential. I do have a video on this on my profile as well. So this will be on YouTube afterwards, but I did recently post a video on action potentials and things like that. And then we have repolarization. There's hyperpolarization. Plus our refractory period. And then we have our resting potential. So our resting potential is our neuron is like polarized, so it's at our normal, so that's like kind of negative 70 MV about. Depolarization is essentially what stimulates sodium channels to open. So Na plus opens and then rushes into a cell. Our action potential is what occurs when we have our threshold potential reached. So again, I'll cover this on a graph here, but I'm just kind of going over some terminology. So this is called our threshold potential. Which is, we reach that, which is negative 55 millivolts. That allows what our impulse to travel down our axon. So an impulse cannot be transmitted until we reach our threshold potential. So resting potential, threshold potential was reached. That is essentially what generates an action potential, allowing to move on to our depolarization. And then we have to get back down to our resting potential. Every cell, every transmission has to rest. So essentially here, our repolarization, this is when our potassium channels open. So potassium opens and rushes out to get us back down to this negative 70 MV. Hyperpolarization, this is when the neuron is temporarily overshooting its resting potential to help get us back to our resting state. So, make sure, show this. So what this looks like on a graph. Essentially here, let's label these. We have negative 70 MV, negative 55 MV, and then we have, I believe for this we have our positive 30. Sometimes it goes to 40. Depends on like what your class like wants you to learn. I go live pretty much every day. So we have, this is our resting potential. And this is our threshold potential, which we went over. So we have our, so we start here and then we kind of have some sodium rushing in here. So it's kind of moving up slowly. This section here is what's called a graded potential. So essentially like this can kind of go up a little bit, it can go down a little bit, it can go back up. But as soon as we reach negative 55 millivolts, this is when sodium channels open and a lot of sodium rushes in, generating our action potential. So we have, let me use a different color. So I'm going to draw this out and then we'll, so this is where Sodium rushes into the cell, generating a very positive value, so our depolarization. So then our action potential occurs, we transmit the signal, and then we have to get back to resting potential. So our repolarization is when we have our potassium rushing out of the cell. And this period here where we're like getting below our resting potential, this is going to be our hyperpolarization. So we're overshooting it so that we can ensure that we're getting back down. And then we're back to our resting potential. Hopefully that helped. I just had an exam on this. The kind of channel a sodium channel is, it's a voltage gated channel, so they're voltage gated, meaning that they have to hit a certain threshold. So again, that's what our threshold potential is. So once we have our threshold reached of negative 55, this electrically stimulates this gate to open, allowing for sodium to rush in. And same thing with the potassium channel. So whenever we reach our positive 30 millivolts, yes, sodium comes in and potassium goes out. We go to 60. Is anyone confused on that? Or does that make sense for everybody? So generally, it's considered that negative 70 is a resting potential, and then it also can go to, so hyperpolarization can cause it to go down to negative 90. Threshold potential is negative 55, and then the inside of the neuron pretty much reaches positive 30 millivolts, which causes, whenever it reaches positive 30 millivolts, that's when our voltage-gated potassium channels open, which is when potassium leaves, bringing it back down. No. What don't we understand, then? If we don't understand it, what don't we understand? Thank you for joining, and thanks for following, everybody. I hope this is pretty helpful for people. Thanks for following, everybody. Thanks for joining. Again, this will be on YouTube afterwards, so the replay is on YouTube, which is linked in my bio. I go live every day, except for Saturday most days, but I actually am planning on going live this Saturday. The time kind of depends. So like 10, it kind of depends on like how work is that day. Solitary conduction is like just a faster way for nerve impulses to travel. So we can explain what this is. So saltatory basically just means that you have increased transmission speed. You have less ATP required, so energy, you don't need as much energy. It's like mainly for our like reflexes, quick reactions, things like that. So it's like kind of the difference between myelinated. So this is what would be considered myelinated. Alrighty, and then kind of piggybacking off of a nerve impulse. So a nerve impulse is considered electrostatic. electrochemical. Why is this thing? So, electrochemical meaning that a nerve impulse within the neuron is electrical. As we just mentioned, our action potentials. So that's why we were talking about voltage-gated channels, things like that. So this is electrical. And then chemical, it becomes chemical once it reaches the synapse or axon terminals. So other axon terminals, it kind of looks like this. It's called an axon. You can call it an axon bulb. But essentially there's these little vesicles and the action potential reaches down here. Calcium is what kind of carries it out here, so it'll get released, and it's called a exocytosis. This is normally acetylcholine, so ACH, and then things like that. So that's when it becomes chemical. So then we have to cover our neurotransmitters. Kind of like what their functions are, what they're associated with, disorderly and stuff. No, this is over the nervous system, general psychology, things like that. But real quick here, let's go over our neurotransmitters. Again, this is more focused towards general psych, but also, this is also for A&P as well. This is stuff that's covered in A&P. Neurotransmitters. All right, so we have acetylcholine. This is essentially what is for our muscle movement, memory. Like I mentioned in our action potential, this is what's released from our axon terminal. This up so I can make some more room. This is generally associated with Alzheimer's disease. Next one we have is dopamine, which is our like reward and motivation, some movement. So whenever you have low dopamine, this is what is known as Parkinson's. And then when you have high dopamine, this is what leads to schizophrenia. And then there's serotonin, which is kind of like our like mood regulation, sleep. This is really what leads to like our depression and anxiety. We have norepinephrine. So I'm going to put norepi, but norepinephrine. This is like our alertness and our arousal. And then norepinephrine is, so when we have low, we have our depression. When we have high norepinephrine, this is what's going to give us anxiety. And then we have GABA. GABA is what I always remembered that. But that's like our inhibitory neurotransmitter. So I put a down arrow for inhibitory. I'll just put inhibit. Or essentially like it has a calming effect. And that's normally with like anxiety, epilepsy. Next one is glutamate. This is our like excitatory, so we'll put excite. This is like learning, memory. So it's associated with seizures, migraines. And then there's endorphins, which are your feel-good hormones. So whenever you work out, you release endorphins. So there's pain relief aspects to it. There's pleasure. But this is kind of linked to addiction. And then our last one that we're going to cover is histamine. Essentially here, this is like our wakefulness. So wakeful. This is our like appetite. And this is like gonna lead to like sleep disorders, or associated with sleep disorders. Alrighty. No reppy. Dopamine is like our reward system. So low would be Parkinson's, high would be like schizophrenia. This is an iPad. This is the second generation 12.9. And no, this is getting me anxiety. I'm so sorry. I just started following you soon. Or just started following you starting AMP soon. Good luck in anatomy and physiology. We'll go live every day. We cover a bunch of different topics, things like that. Yes, there's a difference between neurotransmitter and hormones. So a neurotransmitter is like a chemical messenger. They're both chemical messengers, but they have like differences in how they function, like how they travel. So a neurotransmitter is what's going to go across like our synapse and axons. Hormone is going to be kind of like mostly through the bloodstream. So blood. Hormones have like longer lasting effects. Neurotransmitters are shorter. These are released by neurons. These are released by glands. Just remember, some people leave their dope in the park. Yeah, that's how you. Yeah, that's actually really funny. That's a good one. GABA is my favorite. Seeing neurotransmitters in my pharmacology exam tomorrow. Good luck on your pharmacology exam. Yeah, I can go over T7 material. What time? It kind of depends. If I also miss any questions, I apologize. Please repeat your questions. So sometimes I miss them. 3. How is acetylcholine linked to Alzheimer's? Yeah, we can go over that. So acetylcholine is essentially, so in Alzheimer's disease, you have, so let's go, write out Alzheimer's. You lose your cholinergic receptors, or neurons, sorry. Essentially, whenever you have a loss of these, it leads to decrease acetylcholine levels in the brain. So, again, acetylcholine is responsible for like synaptic plasticity. So that's essentially, so what that means. So when we have lower levels of ACH in the brain, we have decreased synaptic plasticity. Essentially, like I said, what that means is this is our ability to form or strengthen neural connections. So strengthen. So when we have lower ACH, we have lower synaptic plasticity, which means our memory formation and learning are disrupted, essentially. So essentially, we have, with age, we have degeneration of cholinergic neurons in the brain, essentially. Decreasing ACH levels in the brain, decreasing synaptic plasticity, so we have loss of memory formation and learning. Does that make sense for Alzheimer's? Let's see. I have to take the TEAS exam soon. Will be my 3rd time. I'm nervous. Awesome. When do you take your TEAS exam, Reach? Good luck. You got this. Amen. Delayed but never denied. Delayed but never denied. Interesting. Not really sure what that'd be about. So medications that increase GABA and decrease glutamate. So ones that increase GABA are benzodiazepines, barbiturates. There's GABA receptor and agonists. So GABA agonists, like neurosteroids, things like that. These are like the common ones normally. GABA pentanoids. It's like gabapentin. And then for decreasing glutamate, there's called like MNDA receptor antagonist. So that's like amantine, like ketamine, like low dose ketamine therapy type thing. Also called anticonvulsants. So that's like lamotrigine, topiramate. Those are typically the ones for that as well. Alrighty. Okay. Yes, I do know lots on AMP. I'm struggling the most with AMP. I need to do I'm gonna do like a tease. Oh, hold on 1 second, guys. They want me to do a stupid inactivity checker. Oh my goodness. I suck at these. There we go. Awesome. Yeah, AMP is... I love AMP. Yep, Zolpidem, topiramate. Thanks for sharing. Thanks for liking that, guy. Thanks for liking the live, guys. I really appreciate it. But that was essentially all I had for like Psych Chapter 2, things like that. I'm going to do more AMP stuff in just a little bit. I'm going to cover Psychology Chapter 3 real quick. So bear with me, and then we'll switch over to our nervous system questions. So Psych Chapter 3, we have sensation and perception. Sensation is the process by which our sensory receptors detect and respond to stimuli. Perception is the brain's interpretation of that. We have an absolute threshold, which is like the minimum amount of energy, stimulus and energy for detection 50% of the time. 50% of the time. The types of color blindness. I'm just going to lecture here real quick, and then I will take a look at questions. Just bear with me for 1 sec. We have Protanopia, which is like red cones, are absent. We have a very much difficulty distinguishing between red and green. So Christmas is not very fun for those people with colorblind. I'm just kidding. We have our Deuteranopia. Essentially, this is when our green cones are absent. So again, another trouble distinguishing between red and green. We also have Tritanopia, which is where our balloon cones are absent. Our chromatopes, yeah. This is when we have complete color blindness. Complete. Yeah, I can do a tease sometime. I'm late. Not necessarily. We're about halfway through our live, so. We also have our theories of color vision. So we have color vision theories. So we have our trichromatic. Which essentially our retina has 3 types of cones, 3 types. Of cones, which are sensitive to like red, green, blue wavelengths, and our color perception kind of arises when these cones are activated, essentially. Which this does is this like explains color vision at a from the retina, so our retinal receptors. But does not explain why like we have like reddish green colors, like all the different brands of colors and things like that. But we have our opponent process theory next, and that essentially is color is kind of perceived in like opposing pairs like red green, blue yellow, black and white, which would explain that afterimage thing where you can kind of see like a blend of colors, but it doesn't really fully explain color detection. And then we kind of went over schizophrenia a little bit, so we'll cover schizophrenia. Before I move on, let me just check the comments. My friend says you can only see primary colors. Is that a thing? Yeah, that can be a thing for some people, yep. MacBook or iPad, not sure which to buy. Both kind of have their pros and cons. I have both. I'm lucky enough to have both. It kind of depends on like what you're doing. I think that a computer obviously makes certain things a little easier, but for like if you're someone who has to take a lot of notes and things like that and write things out and do a lot of problems, I definitely think that iPads are pretty good, but I think you should get a computer before you get an iPad for school, for sure. But an iPad just can't really do, yeah, Brianna says I can't do it all. Yeah, it just can't do everything. It's good like for an extra thing, like if you save up and have the money for it, yeah. But an iPad can easily be replaced by a notebook. It just makes note-taking easier and faster. But a computer is like a, do-it-all kind of thing. I've been leaning on the MacBook side. I just love I love my Apple Pen. I love my iPad. It's my baby, honestly. How can I memorize the cranial nerves? Okay, so I do have some mnemonics on that. If you look I have a video on that, but essentially, it's like, once one takes the anatomy final, very good vacations are here. That's like the mnemonic that I use for that. Alright, but moving on. Schizophrenia. Schizophrenia is a very severe mental disorder, essentially where people have a lot of trouble thinking, perceiving things, emotional behavior. They very much, it's called psychosis, so they have a very bad sense of psychosis. Essentially, it means that they lose touch with reality. The symptoms of that, again, losing touch with reality, there's hallucinations, delusions, disorganized speech. The negative symptoms are essentially like our flat effect, meaning that they have reduced emotional expression. Logia, which is reduced speech output. Anhedonia, which is a lack of pleasure in activities. They have social withdrawal, so they avoid others. The risk factors, there's genetics, obviously. There's prenatal factors, so viruses, malnutrition, utero stress, brain abnormalities, like reduced gray matter, neurotransmitter imbalances, which we kind of went over up here, wherever that went. So we have issues with our dopamine. So we have overactivity of dopamine. And then childhood trauma, drug use, things like that. Alrighty, but that essentially covers what I wanted to cover for general psychology, chapters 2 and 3. I am going to take just like a 2 or 3 minute break here real quick just to use the bathroom, and then I will be back, and I'm going to cover some nervous system questions. I'll answer some. What is my study plan methods in terms of holding on to information? So I typically, we'll go over this real quick. So my study plan, right? So if I have, let's just say Tuesday is my lecture, and it's from 12 to, normally they're like an hour and 20, so let's just say to 1:30. So I will preview the lecture for 20 to 30 minutes, either the day before or the morning of. I do not take notes during class. I pay attention, so listen, and I print out the lecture slides, or I put them on my iPad, so I write over top of lecture slides, so right on lecture slides. And then after class, for like an hour or two, this is when I make my notes from class. And then once I make my notes, I'm going to be watching your stuff because I need a refresher in Anatomy 1 and 2 before I do the HESI. Oh, good luck. My lives are recorded. Oh, heck no. For me, that was 160 slides. My class is online and self-taught, SNH. You can do the same thing here in terms of lecture. Like if you have a recorded lecture, if you have a textbook. Like what I would do if you just have a book instead. Preview the book. Just go to the end of the chapter. There's always a summary. For previewing a book, look at, or a textbook. Let's do textbook. Look at end of chapter summary first. That's how you can preview that end of chapter summary. But I go through and I make my notes, and then after that, how I study is I will normally textbook and YouTube links. Oh my goodness. Yes, I do preview every class. My lives are on YouTube, so live, and it's linked in my bio. Live replays on YouTube. And then how I study is, so I've made my notes, and they serve as my reference when I'm studying. So I will have, my notes here, and then I will go through and I will explain them. I will look at them, I'll read my notes, and they're kind of condensed, so they're just bullet points, short, like wordage, very, not full sentences. I will look at the material, I will look away, and I will see if I can explain it out loud. So, like if I have this here, a glial cell. So I have a non-nervous cell in the nervous system support. So this is what like a note would look like when I make them after my class. So I would go through to study this. I would read this, so read through this, and then I would look away, and then I would be like, okay, so what is a glial cell? A glial cell is a non-neuronal cell in the nervous system that functions to support, protect, and provide nutrition for neurons, and essentially maintaining homeostasis for neurons, and they also can be responsible for forming myelin. And then I would look over there and see, okay, got that, and that. So that's essentially how I study. How do you recommend studying the day before an exam? You have 20 chapters to get through still. 20 chapters in a day. Oh, jeez. What's it on? Are you cramming? Because if you're cramming, honestly, praying to God. That's what I think. Yeah, don't procrastinate the next one. That's for sure. Microbiology. Oh God, that's even worse. I would. Yeah. Ooh. Pray. Maybe. So, essentially, to cram here. If you got to cram. Cramming 20 chapters. How many hours are you trying to study? Let's start with that. How many hours are you trying to study? How many hours do you have to study? Let's go with that. We'll start there. When is it? It's tomorrow, right? Is that what you said? Probably an all-nighter? Yeah. I would essentially focus on like big picture ideas. I don't know, that's a hard one. I took microbiome and there was no. I honestly not sure that I could cram it. But essentially, if you have study guides, start there. I would just focus on the big picture things. I would maybe use look through like your key terms, like go through every chapter and look at the key terms. See if you can find a Quizlet online and just like kind of briefly practice. So learn your terms. I would just read through kind of like it's called blurting, essentially what I just explained. Like read some high topic stuff, look away, see if you can explain it real quick, and then move on. But I definitely wouldn't make any notes or make flashcards at this point. That's just a terrible idea. Sorry. Negative symptoms would be here. So sorry about that, Kelly. So our negative symptoms. So it's called a flat effect. So decreased emotion. So it's called our alogia, which is decreased speech. Anhedonia. This is our decreased pleasure. And then we have decreased social activity. Thank you so much. Hello. How are you guys doing? Again, I'm about to take like a 2 or 3 minute break here, and then I have some nervous system questions, and then we'll go through those. So I'm gonna end the live real quick. I will be like right back. I just have to go to the bathroom, and then we'll get back to it. Does that sound good for everybody? Again, all my lives are recorded, and they will be on YouTube, which is here. I appreciate you guys all following. But I do have a couple nervous system practice questions. We'll go through and we'll do the explanations, and we'll do those pretty quickly and things like that. But again, I will be back. Just give me like 2 minutes.